All right, what I want to look at today is the law of cosines. We looked with the law of sines at situations where we knew any two angles and a side, so we had either angle side or angle angle. We also looked at the ambiguous case, side angle, where you had to be careful to, when you were given two sides and an angle, occasionally you could get two different results, and occasionally you would have situations where it was impossible to find a triangle with those dimensions. Okay, but now we're going to look at two other cases, two other situations where we're either given all three sides or we're given two sides and the angle between them. Okay, so it's not side angle, it's side angle side. And we'll look at examples of how to solve both of those using our law of cosines. But before we get to that, I actually want to derive the entire law of cosines so you guys can see where it comes from, how it relates to other things that we've done in trig, and then hopefully have a better understanding of how this whole thing works. So let's start out with this situation. I want to set up this situation and make sure you understand what all this is. I made triangle ABC to where C is at the origin on my coordinate plane, and this side BC is going to be A units long because it's across from side A. So point B would be the point A0. Okay? Now, the key to this whole thing is getting these coordinates for point A. Now, understand, I have it drawn this way, but this method applies whether it's drawn like this or whether A was like this and you've got this triangle, okay? Or even if A were all the way over here and you had this obtuse triangle. Okay? It works the same. That's why we use this arbitrary point. Alright? So let's look at how we actually get those coordinates for it. Okay? You'll notice I started the same way we started when we derived the law of sines and when you guys did the side angle side to find the area. We dropped this height down. Okay? The difference is here, now this height is not only the height of the triangle, but it's also the y coordinate of this point. Alright? And where it hits the x-axis is the x coordinate of that point. So now what we're going to do is we're looking at the situation as though we're given a side and another side and the angle between them. Okay? So those are the only three things that we want to be in our final solution. Side B, side A, and angle C. Okay? And our ultimate goal here is to figure out what side C is. Okay? So, let's look at these coordinates first. How did we get B cosine C and B sine of C? Well, like we did when you guys were getting the area, we're going to use a trig function with angle C to express, and use side B to express side Y. Okay? So Y is in this right triangle opposite angle C, and B would be the hypotenuse. So what trig function am I using? Sine. Alright? We're going to use the sine of angle C, and that equals Y over B. And then, of course, we can simply multiply both sides of this equation by B. So Y equals B times the sine of C. That's how I got this Y coordinate here. Alright? Everyone understand that so far? Okay. Now what we're going to do is we're going to do a similar process to help us find x. Okay? This is b times the sine of c. Should make that a capital C. And now we are finding x. Well, x is the side adjacent to angle C. So since I have the adjacent and the hypotenuse, what does x over b equal? The cosine of angle C. So therefore, I multiply both sides by b, and I get b times the cosine of angle C. Okay? So I'll write that in. Now, just with that, we don't quite have enough to be able to find what that point C is. Okay? At least not using the Pythagorean theorem. It's possible we could use the distance formula at this point. You guys remember how to find the distance between 2 points? We could do the distance from A to B. That's one way to derive the law of cosines here. Another way is to use the Pythagorean theorem. That's what we'll use here. Okay, so how are we going to do that? Well, if you look here, we have a triangle, a right triangle that C is the hypotenuse of. And I know that this side here is b times sine of C. Okay? So now all we need is an expression for this side going from here to point B. Can anyone tell me what that might be? Good. Good. A minus b times the cosine of C. This whole side is A. This piece is b cosine C. So this is what's left. So you subtract. Alright? So if you notice here, now we have a right triangle where we have expressions for all three sides. We can use the Pythagorean theorem. Okay? And here's the deal. I'm going to have you guys try to do this. I only want A, B, and the cosine of angle C in our final formula. Alright, this is the law of cosines, so we shouldn't have any sines in our final formula. Alright? So take a couple minutes, feel free to work with somebody, but try to use the Pythagorean theorem with this triangle here to figure out what, you're not going to get a value for C, but to get an expression that will equal C. And feel free to work with somebody.
突然要睡觉，我刚才还掐了自己一下，自己醒，而不想听歌。听讲故事就好了，困死了。
If you think you got it all the way, let me see and see how you did. There's at least a starting point if you haven't thought of that yet. Well, we're not going to get any values. We just want to simplify that down.
But if you were to do the same thing with B, the same equation.
Yeah, if we kind of turn the whole thing around and yeah, you get a.
Okay, that's what I was doing.
The letters would be in a different position, but it would be the same idea.
I think I got it very much.
you square something, it becomes positive.
There.
And so is that. I'm not sure where the negative came from that for that one, but
Oh.
yeah, that's good.
Yeah.
No, that would equal c squared. And that's okay. We'll leave it equal to c squared. I would FOIL it before I'd split it. Yeah, we don't want any sine c's in our formula. Yeah. So now go ahead and, yes, that's correct. Yes, yes. Well now, yeah, distribute that b squared in your there.
And then you can just like stop after that.
Yes.
Doing this for later, and then doing this for
You don't have to. At this point, let's do this. And this. Yep.
还需要3秒内能求出来吗？乔恩大学霸那个听众。哪条边是哪条边啊？
Oh, okay. So, is there a pen?
There you go.
Thank you. What the test actually should be the
What do you
40
have?
Okay.
but we might have like a quiz or something like that while you're gone. Thank you. Alright, so let's take a look at, some of you are getting there, some of you got there, that's good. Let's take a look at what we would have here. Okay, we use the Pythagorean theorem, and we have to FOIL this first part, okay? So if you FOIL this, you have an a squared minus 2ab cosine c plus a b squared cosine squared c. That's all just this FOILed out. Okay? Then we have this squared, so it's plus b squared sine squared of c. Okay, and this all equals side c squared. Now, at this point, there's a couple ways you could go with this. Some of you plugged in a 1 minus cosine squared here. That's great. Okay. Personally, I usually will take this b squared and factor it out of those two terms. And then what's left in the parentheses?
cosine squared c plus sine squared c.
And what's cosine squared plus sine squared? 1. Okay? So, I have a squared minus 2ab cosine of angle C plus b squared, and that equals c squared. Now, I'll show you that's okay. Typically, when we'll write this, though, we'll put the a squared and the b squared at the beginning. So it'll be a squared plus b squared minus 2ab times the cosine of angle C equal to c squared. And that is our law of cosines. Okay? Notice you have all three sides and one angle involved in this formula. So you either have to know two of the sides and the angle in between, side angle side, or you have to know all three sides and you can then figure out one of the angles. Okay? I'll give it to you in a little neater format right here. Okay? The biggest thing to remember here is that whatever side is over here on this side of the equation by itself has to be the side across from the angle you're using. Okay? And that's true whether you're solving for the angle or whether you're solving for the side. Okay? So here's the thing, when you're using this to solve for things, you're either going to be solving for this angle or you're going to be solving for this side. Okay? You should never have variables in here. Okay? Oh, whoops. Thought I'd block that. Okay? So, you're solving for one of those two values. If you're given side angle side, then everything on this side of the equation will be plugged in and you're just solving for side C. If you're given side side side, then all of these lowercase letters, all of those will be plugged in, you're solving for the angle. Okay? Yes?
If, say, we were trying to like measure side B, so it would be B squared, and then how would we know, well I guess, so the A and B are interchangeable, right?
A and B and really C, all of those are interchangeable relative to what angle you have.
Okay.
If you were trying to find side B with this formula, okay, you would have to know angle B. So you'd be using the cosine of angle B, and instead of A's and B's here, you'd have A's and C's.
But it doesn't matter where the C is.
It would be that, okay? So now, we derived this because I want you guys to understand where this comes from, because it makes it a whole lot easier to remember if we know where it came from, okay? So, for me, sometimes I have trouble remembering, is that a 2 or a 4? Okay, because quadratic formula, you had the minus 4ac thing. Well, if I remember that came from foiling, okay, I remember that came from foiling, I remember, hey, it was a minus 2. Okay? So it'll help you remember. Also, recognizing the overall structure that you have here, where this side is across from this angle, we don't need to memorize 3 different variations with all the letters interchanged. We understand the structure of the formula, and we can then use it properly, okay? So let's now take a look at, if we're given side angle side, how would we find the third side, all right? This is the easier way of solving, or the easier thing to solve for when we're using the law of cosines. Okay. Block that. Now, the formula that we were given had C, okay, but we're solving for A, so we are going to have to interchange some parts. The thing that I'm going to be using, since I'm solving for A, I have to use angle A, And instead of A's and B's here, I'm going to have B's and C's. Okay, so it's B squared plus C squared minus 2BC cosine of A. Alright, so I adapted the formula that we memorized to fit what I'm looking for now. So now it's just a matter of plugging stuff in. We have 21 squared plus 15 squared minus 2 times 21 times 15 times the cosine of angle 10. Okay? Alright, so 21 is 441. 21 squared is 441. 15 squared is 225. And 2 times 21 times 15 is 630? 630. So minus 630 times whatever the cosine of angle 10 is. Okay. Okay. This, at this point, you can just punch in your calculator. And what do we get for a squared then? 45.57 and so on. Okay. So I leave that in the calculator and then I take the square root. And you get 6.75. Now I'll round because I'm at the end. Okay? Yes.
So with the law of cosines, it's not going to ask you to solve the whole triangle, right? It's just going to ask you, will it ask you to solve the whole triangle and you can use both law of sines and law of cosines?
Yes, that's kind of the idea. At this point, if we were trying to solve this, we couldn't use the law of sines. But once we figure this out, that this is 6.75, now I can use the law of sines because I have this pair across from each other. Okay? And of the two angles left, which one could possibly be an obtuse angle? B, because that's going to be the biggest one, right? So if I'm going to use the law of sines to find a second angle, which angle should I find next? C, because I know it's going to be acute. I can avoid that ambiguous case, right?
What do you mean by, if B is obtuse, you can't find the law of sines?
Well, remember with the law of sines, sometimes, notice now we would have side-side angle. In that case, sometimes you had two different possibilities. So if I used the law of sines to find B, I'd get an acute angle, but sine could also give us an obtuse angle, and we wouldn't know which one it is. Okay? That's why I said, since I know that this is the only one that could possibly be obtuse, let's find this side right here, because I know it's going to be the middle length, or the middle measurement, and it won't be obtuse. Okay?
But then when you still have to find B.
You would, but how would we find B?
And
180 minus 2.
We're subtracting from 180, and that'll tell us for sure if that was obtuse or acute. If it was acute, then, hey, it wouldn't have hurt either way, but if it was obtuse, then we definitely would have wanted to do C next. Okay? In fact, this one I think it would end up obtuse, so it's helpful. Yeah.
To find B, can we do like 7.75 over sine A equals 21 over sine of B?
You could, but that's an ambiguous case. We wouldn't know if angle B was acute or obtuse. So what, so I'm trying to avoid the ambiguous case. So I find C by doing sine of C over 15 equals the sine of 10 over the 6.75. Okay. I do that because I know for a fact that C is going to be acute. Then I'll just subtract to figure out C, or figure out angle B. Okay? So does everyone understand the law of cosines? Alright? Alright. Now, our other case is when we're given side, side, side. And again, you can use a simple strategy to avoid that ambiguous case when solving a right triangle, or solving an oblique triangle, okay? When you're given all three sides, we said there was no ambiguous case for the law of cosines. Alright, it was only going to happen for the law of sines. So when you use the law of cosines, given side, 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 go ahead and find that largest angle first. Okay? We could find any of the angles at this point, but it's helpful if you go ahead and find the largest angle first. Which one in this case is going to be the largest angle? C, okay? That's the only one that could possibly be obtuse. So I'm going to solve for it using the law of cosines, so I don't need to worry about the ambiguous case. Alright, so I know I'm going to have a cosine of C. What has to be the side over here?
8 squared.
8 squared, okay? Make sure you use the side across from the angle you're looking for on the other side of your equation. And then A and B, it really doesn't matter which one we call which. Technically, A here would be 6. So 6 squared plus 3 squared minus 2 times 6 times 3 cosine of C. Now, take a moment and try to solve this.
Equals 9 cosine C. 9 plus cosine C.
Okay. How have you got that?
I didn't.
How many of you got that? 9 cosine C.
Because it's, you have to subtract these. Yeah, you have to divide by these.
Yeah. Number one mistake, okay? And if you made this mistake, don't worry, because this is the number one mistake when solving for an angle with the law of cosines, is we go ahead and combine all three of these numbers, because they're so close to each other, right? But remember, this one is times the cosine of C. So, you can simplify this a little bit, but it's 45 minus 36 cosine of C. Alright, don't combine these two, because this has the cosine C with it.
I got a negative as my answer.
That's okay, alright?
Like, as my answer for what C is.
For the angle itself? Okay, that, did you hit cosine? Inverse cosine?
Oh, I used sign.
Yeah. Make sure you just hit inverse cosine. So we subtract here 45 from 64. That gives us 19. Okay, and that's a negative 36 cosine C. So now I divide by negative 36. And I know that cosine of angle C is going to be a negative 19/36. And that's 0.5 something. Negative 0.5 something. So now you hit inverse cosine, And by the way, before you even hit that, looking at this, what do I know about angle C?
It's gonna be less than 1.
That's less than 1.
It's gonna be in the
But-
second or third quadrant.
Okay, it's going to be second or third quadrant, and since we're in a triangle, we know it's going to be
Second.
second quadrant. We know we're going to have an obtuse angle because cosine is negative. Okay? So, what did you guys get for angle C then? 121.86, so we'll make that 121.9. We'll round to 1 decimal point.
Maybe.
Alright? So it's a good thing we used the law of cosines to find this, or otherwise this would have been one of those ones that the law of sines would have been unclear on. Okay? Yes?
Hey, I'm just confused how you know when there's gonna be 2 different answers or an ambiguous case.
It'll only happen when you're using law of sines, and it'll only happen when the angle you're getting could be the biggest angle. Okay?
So if we were solving for A, that wouldn't be a problem.
Yeah. And here's the thing, you don't absolutely have to find the largest angle first. But now I've got to use the law, I can use the law of sines to find either angle A or angle B, and it really doesn't matter which one I find next, because I know both of them have to be acute. Alright? Because I already got the biggest one. So if there was an obtuse angle, it's right there. I know for a fact those two are acute.
Yeah, we should just always solve the big angle first with cosine.
That's what I would do. Okay? So, kind of a general rule, if you're using the law of cosines, get the biggest angle first. If you're using the law of sines, leave the biggest angle till last. Okay? And just subtract to get it. Okay? Alright. Now, there's one last thing I want to look at here, and this is a second area formula. If you want the proof of this, it's at the end of the chapter. I'm not going to do the whole proof of this one, but it's an area formula that actually was derived. There are 2 derivations. One uses a triangle inscribed in a circle. Okay, that's how it was originally done. And then there's also a proof of it that uses the law of cosines. Alright, I'm not going to show you either of those for time's sake. But the person who came up this, his name was Heron, so this is known as Heron's formula. Okay? And this is for finding the area when we know all 3 sides. Okay, we already have an area formula for when we know 2 sides and the angle between them. The 1/2 AB sine of C. But here it's for when we know side, side, side. Okay? Now, let's think about this for a moment. If you know all 3 sides, what fact about the triangle can you find really easily? Perimeter. Okay, add up the sides and that's your perimeter. Well, this uses something called the semi-perimeter. What does the prefix semi mean?
Partial.
Partial, more specifically, half. So what do you think the semi-perimeter is? Half the perimeter, okay? So we need to define this variable s as the semi-perimeter. It's half of the perimeter, okay?
Complicated formula.
Yeah, okay? In case you forget what the word means, there it is, okay? You add up the sides, divide by 2. That's your semi-perimeter. Now, we're going to use that in Heron's formula here, okay? The area of the triangle will equal the square root of this whole product. And look carefully at what we're taking the product of. It's the semi-perimeter times the semi-perimeter minus each side. Okay? So s times s minus a times s minus b times s minus c is all inside that square root.
Mr. Erickson,
Yes?
you said we knew the area for the what other thing? The side angle side?
Yeah, if we know side angle side.
You know the area?
We can find the area. If you remember, we had area equals base times height divided by 2. That's the classic one. But then we also knew it was 1/2 A times B times the sine of the angle between them. Okay, that's if we know side angle side. Alright, A and B would be the sides, C would be the angle between them. Okay, here though, we know all 3 sides.
Okay.
Okay. So, we already looked at this triangle on the previous slide. We found the angles of this triangle. Now let's find the area of this triangle. Okay? So, the first thing that we want to do is calculate what the semi-perimeter is. Alright? So, find the perimeter, divide by 2, and what do we end up with? 8.5, okay? 8 plus 6 plus 3 is 17. Divide it by 2, and you get 8.5. Now we're going to plug that into our formula. The area equals, put your big old square root there. There it is. Okay? And then you have the semi-perimeter, don't forget that at the beginning. But then that's times the semi-perimeter minus each side. Okay? So it's minus the 8, minus the 6, minus the 3. Now, this is one of those formulas where you'll help yourself out by thinking and not relying on your calculator too much. All of you can do that subtraction in your head. Okay? So don't rely on your calculator for that. This is the square root of 8.5 times 1/2 times 2.5 times 5.5. Okay? So then this is the square root of, what is it? Is it like 0.43, so on, okay? So that equals 7.64 for repeating, okay. So that'd be 7.64, and whatever units we're in, it would be units squared. Okay, because it's an area now, so we should have square units. Okay. Does everyone understand that? Pretty clear? Okay. So it's a relatively straightforward formula. You just have to be careful with it. Don't rely on your calculator too much, because that's when you lose parentheses or something like that. And you end up missing something that you knew how to do, okay? So just be careful with it. And 2, make sure your answer makes sense. Alright? Don't forget to square root at the end, all that good stuff. So you don't lose little points here and there. Alright, so what we're going to do at this point, we have all of the tools that we're going to use in solving our triangles. Okay, the law of sines. Obviously we have a right triangle trig from before. So if you see a right angle, don't forget you can use right triangle trig if you have a right angle in there. But we have the law of sines, the law of cosines. We have our 2 area formulas as well. Okay, so I'm going to give you kind of a challenge here that will take the remainder of our time with, and that is finding the area of a quadrilateral. Okay? Now, we only have triangle area formulas. So what are you obviously going to have to do?
Break up the triangle.
Break it into triangles, okay? You don't need to break it into more than 2 triangles, alright? Some other people were breaking into like 3 different triangles. You don't need to do that, okay? But you will need to solve some of those triangles, or at least for some of the parts of those triangles, to be able to get enough information to find your areas. Okay? So, I'm going to let you guys work on this, and feel free to work together in groups. You can move your desks. If you want to work on the board, you can. Alright? We'll see how you guys do with this. Alright, if you're watching the video, you might want to pause it, and then I'm going to show the results down in the bottom. You can look at it later. Okay, so there's if you divide it that way, and there's if you divide it the other way. You can see that. Alright.